So now we want to solve the logarithmic equation log base 2 of x minus 2 plus log base 2 of x minus 5 equals 2. So the name of the game when you start these logarithmic equations is to combine logarithms as much as you can. You want to simplify the equation by condensing the logarithmic expressions. So on the left side of this equation you have the sum of two logarithmic expressions. The first thing you should do is combine those and express it as log base 2 of this, x minus 2, times x minus 5. I'm going to put brackets around all that. Equals, we have 2 on the other side. And I think I'll go ahead and multiply out what's inside of that logarithm. I think that might make it look a little nicer. So this is, if you FOIL here, x squared minus 5x minus 2x, so that's minus 7x plus 10 equals 2. Now, logarithmic equations come in kind of two main flavors, two main types. Log equals a number, like you have here, or log equals log. So you combine your logarithms. In most cases, you're going to find yourself in one of those two scenarios. When you have log equals a number, the way that I advise you guys to approach that is to change it to exponential form. And let me just put in writing, this is what I advise whenever you have log base b of m equals a non-log, I mean I'm going to put a number here, but really any non-log expression, then your best bet is to change it to logarithmic form. If this were log base 2 of all this equals log base 2 of 2, if you had a log on both sides, that's kind of the easier scenario. When you have a single log on both sides, same base, you can just drop the logarithms, set what's inside equal to each other. So students always have a little easier time with those types of equations and a little bit of a harder time with this type. So when you have log equals a number, change it to exponential form. So in this case, the base is 2. The exponent is 2. Remember, log always equals the exponent. That's what log does. It solves for what power of this gives me this. So if it's equal to 2, 2 is that critical power of 2 that gives us all of this. X squared minus 7x plus 10. Well, 2 squared, that's 4. And now we're back in a chapter 1 problem. We've got an quadratic equation. So with quadratic equations, you usually want to have 0 on one side. So I'm going to subtract 4 from both sides. X squared minus 7x, so now this will be plus 6. Two numbers, we want two numbers at this point that multiply to give us positive 6 and add up to negative 7. And we can do that. I mean, if we couldn't, we would have to use the quadratic formula. But thankfully, if we use x minus 6, x minus 1, let's double check. You'll get x squared minus 1x minus 6x will give you minus 7x plus 6. So we're in good shape. Set each factor equal to 0, we get x equals 6 or x equals 1. Now, one last thing with logarithmic equations, you should double check, take each of these x values, substitute it into the original equation, and make sure that it does not result in log of a negative number. A logarithm of a negative number is undefined. This is similar to when you solve equations involving fractions, so like 5 over x plus 2 over x plus 3 or whatever. You do a bunch of work. If you wind up down here with x equals negative 3, you had to toss it out because it would make a denominator 0. Similar sort of thing here. If you take what you have down here, plug it in. If it results in log of a negative, you have to toss it out. But if x is 6, this is 6, that's positive. 6 minus 5 is positive, so we're in good shape with that one. If x is 1 minus 2 right here, you're going to have log of a negative number. And 1 minus 5 here. You cannot take log of a negative number, so that's an extraneous solution. We have to toss that out. And the only solution to this equation is x equals 6.